Okay, we will talk more data wrangling. So we looked at data wrangling functions with dplyr, filter, and mutate, and summarize, group by. So we'll take a look at that some more. We didn't finish a couple of the slides from Monday's lecture, so I'm going to go over those now, and then I'll also just do some more examples here. Okay, so here is just a fictional data set. Okay, where we have three countries: ABC, Afghanistan, Brazil, China, and then some fictional. We have years: 1999 and 2000, sex, female and male, and then cases of, I guess, cases of something. Okay, and we just have ones, twos, and threes. But this is just to kind of show how summarize and group by and all of this kind of stuff works. Okay, so if I say group by country and year, okay, basically it's going to group. It's going to create 6 groups. We've got Afghanistan 99, Afghanistan 2000, Brazil 99, Brazil 2000, China 99, China 2000, right? We said create groups using country and year. So it's going to create 6 groups. And then my summarize is just going to be sum the cases. So remember, we have a bunch of ones and twos and threes. So summarize here, we add them together and we get 2, 2, 4, 4, and 6 and 6. Okay. If you call summarize on this again, okay, so here the top level data set has 12 rows, and we said group by country and year, okay, and so the resulting thing, we have 6 rows here, but there's an even higher level grouping, country, okay, so we have Afghanistan 99, Afghanistan 2000, but within that, there's kind of another grouping of, at the top level, country. And we have 3 groups. We have A, B, and C, okay? And so if I say summarize on this again, okay, so it says country 3, summarize on this again, now it will combine those and we get Afghanistan, Brazil, China. And then if I call summarize on this again, now there's no groups and it just adds everything together into 24, right? So it's kind of like you're creating a hierarchy of groups here. And then every time you do this, there's an additional layer of groupings that you can kind of continue to run summarize. So even though I don't explicitly call group by over here, I just say summary one table and summarize it there. We have this. I think tidyverse will give you like a heads up, and you might say like the result is grouped by this. And if you want to get rid of the groups, use like ungroup or whatever. Like you'll get a warning, or not a warning, just like a message. Okay, messages and warnings aren't necessarily bad things. Sometimes students are like, oh, is it okay that this message appears? Okay, well, read through the message yourself and just ask yourself, does it make sense that this is a here? Fine, and that's a lot of times it's fine that the message appears. Okay, sometimes you have a warning. Okay, and a warning is where R kind of suspects this isn't what you wanted it, right? It's what you wanted. So if you try to add like say 2 vectors and they're of different lengths, R might say, hey, are you sure you wanted to do this? Because I'm getting kind of a funny result where they're not the same length, type of thing. And so you just kind of get warnings and again, ask yourself, is it okay? Is this what I want? And if the answer is yes, then it's fine, right? I think like when you do the penguins data set, you get a warning. It's like, hey, we couldn't show 2 rows because they were NAs, and it's just like, are you sure? And in that case, yeah, that was fine about the data. Okay. Errors, on the other hand, means like R couldn't figure out what to do, so it just stopped running. It just says, you sent me to the grocery store to buy this, and you didn't give me enough money, so I can't come back and do this, right? A warning would be like, you sent me to the grocery store to buy milk, and there was like 5 brands of milk. So I just picked one of them and just giving you a heads up. I'm not quite sure if this is what you wanted, but this is what I did, type of thing, okay? Okay, if I change this and I say, hey, group by year and country, okay? So it's pretty much like the same thing over here. I said, back here I said group by country and year. But now if I group by year and country, notice the hierarchy here. I have 1999, 2000, and then 1999, Afghanistan, 99, Brazil, 99, China, 2000, Afghanistan, 2000, Brazil, 2000, China, okay? So there is a hierarchy here, and what's the top level grouping? The top level grouping here is year, okay? Because I said group by year first, then country. And so if I call summarize on this, it's going to use the top level grouping, and it will group 1999 together and 2000 together. So we get 12 cases of 99, 12 cases of 2000, okay? So this slide and this slide are quite similar. The only difference is this and this have been swapped in the order. And the results are quite a bit different, okay? So there's a difference there, and I want you guys to be aware of that, okay? All right, we're going to do some more examples. I just want to show you some more examples of data wrangling. So here I'm going to load up the Gapminder data. So remember, the Gapminder data is kind of like we have all of these different countries across from 1952 to 2007 in kind of 5-year increments, and we have life expectancy, population, and GDP per capita, along with, but again, shortcomings of our data set is that, there's the countries and the borders have changed over the past 60 years, or I guess this is 73 years ago now, okay? A lot of these things have changed, but just kind of to make the data set manageable, they've just extrapolated and guessed some of these numbers for back then if the borders have changed, okay? All right, anyway, we're gonna call summarize on this. And so remember, summarize kind of takes the values in a column and makes a summary statistic out of it, okay? And so we're gonna take multiple values and make one entry. This is different from mutate. Mutate takes entries in a column and creates a brand new column where you're gonna have values kind of calculated for each row. So like if I did, I don't know what value would be useful to calculate, but if I did like population times GDP per capita to kind of get like the entire GDP or something, I could mutate that, right? So I could do population times GDP per capita to kind of get the entire GDP of that year or something, and it would calculate it for every single row here, okay? But summarize isn't doing that. It's just going to kind of create, it says like take all of the values in GDP per capita and give me the mean, or take all of the values in life expectancy and give me the mean or the standard deviation or something like that, okay? And so we have different things. We can calculate the mean, standard deviation, median, quantiles, which basically is how we calculate percentiles. And then if we have missing values, we use na.rm to tell R to ignore missing values. This is, sometimes it feels annoying that you have to type in this na.rm. But this is just a reminder to you that you are ignoring missing values, which may or may not be what you should do, right? Like, for example, if I tell you a family has 4 children and I know the ages of 2 of their kids, their 2 youngest kids are 5 years old and 7 years old, and then I say, hey, what's the average age of kids in this family? You would not say, okay, well, the average of 5 and 7 is 6, and the answer is going to be 6, okay? You wouldn't say that because I just told you there's 2 other kids, and they're older. We just don't know what they are. So your answer has to be, well, I can't really give you an answer unless you tell me how old the other kids are, all right? And so the answer is, I don't know. And that's basically what R says. Every time you give it a list of values or vector values and you have missing things, R says, I can't tell you what the average is because I don't know what these missing values are, okay? Now, so you have to explicitly tell R, give me the average of the ages we do know. And then you say, okay, well, the only ages I know are 5 and 7, so the average so far is 6. But that's different from what's the actual average of the ages in this family. Okay. All right. So anyway, here I'm just saying, let's take our life expectancy numbers and let's calculate some summary stats. Right. Let's get the average life expectancy, the standard deviation, the minimum, the median, the third quartile, the 75th percentile, and then the maximum. Okay. And so this is what we have. The average across all whatever 50 years from 2007, 55 years, I don't know, 1952 to 2007, the average was 59.5 across all of the years, okay, et cetera, et cetera, et cetera. Now, I keep having to throw in like different kind of caveats here. Here we are taking every entry in here and we're treating them equally, like equal. And that's probably not like the best way to do something, right? Like in if we just say like, hey, what's the average income in the United States? Okay. Maybe I can give you like 50 separate states. And then, but you wouldn't want to just take like California's average and Wyoming's average, okay? California being the most populous. I think Wyoming's the least populous. And you know, you don't want to just average them together, right? You'd probably want to create like a weighted average or something like that. It's weird. Life expectancy is like a weird number. I don't even know how we calculate life expectancy, honestly. How do we calculate that? And we just kind of assume that like, oh, this life expectancy number is, but actually I don't know how it's calculated because do you just take the average of how old was everybody who died that year? I don't know. Is that how how do we, but then that's the average age of death, which is different because like we're all alive today and we're all gonna die at some point and we don't know exactly when we're gonna die, and I don't know. Anyway, so do you just take these averages? I don't know. Do I multiply it by population? I don't know. But anyway, we're just treating all of these numbers as the same and we're just taking the average. So probably not the best idea, but anyway, this is, what else are we supposed to do? So that's what we have, okay? So, so I can kind of do some stuff like this, and then so because I just did summarize on the entire thing, I just have one row. It just says take the entire column. There's 1,700 rows. Take the entire column, give me the average of this column. Take the entire column, give me the median. Take the entire column, give me the minimum and the maximum, and so on and so forth. And this is what we have, okay? I could say, hey, let's just do this for one of the years. So the most recent year in the data set is 2007, so it's kind of an old data set already. I don't know. Were some of you born in 2007? Maybe. Okay. Yes. All right. So this data set is as old or older than you, and we have, okay. So this is the life expectancy in 2007 and the population and all of that, right? So that's if I filter this, and here we're just looking at the Americas, North and South America. Okay. I can run summarize on this and just say, hey, what was the average? And, you know, in 2007 in the Americas, we have 25 rows and we got this average and minimum, maximum, and so on and so forth, which is quite a bit different from the entire data set, right? So the min was 23.6, but that's going across back to 1952, looking at all of the continents, all of the countries. And here, if we limit ourselves to 2007, the minimum was 60.9. So that's different, right? And then I could say, hey, let's do this again, but just for 2002. But again, you know, and we get slightly different numbers. we probably don't want to do this. So the way we kind of take care of this is we're going to group by year. All right, we'll group by year and then calculate all of these summary stats. So then doing this for the Americas, it got cut off, so I'll just show you the result. But I say, hey, let's look at the Americas continent. We'll group by year, and then we'll calculate the summary stats across all of the years. And so we'll see, some kind of trends, and we can say, all right, in 2007, the average life expectancy across the North and South America continents was this. And if we go back to 1952, it was lower. And as time went on, this life expectancy continued to climb. So that's that. The minimum also climbed. The maximum started off at 60.8 and looks like it climbed, not as dramatic improvements. So you get the biggest improvements usually with like access to healthcare, where if women are able to get medical treatment during childbirth, improves the survival of children and infants, and then survival chance of women, and that's going to dramatically improve life expectancy. And that's probably one of the biggest kind of advances we've made as far as medical wellness in the 20th century. Okay, so going from 1952 to 2007, we see dramatic improvement on the minimum. On the maximum side, not as dramatic improvement because we can kind of assume a lot of these nations already had pretty good access to healthcare already. But we see this. Okay. So that's what we have going across there. Now, you might want to take this summary table and then plot it, okay? And so we can kind of take this table, which is the result of all of this operation, and we can pipe it directly into ggplot, okay? So I could, if I wanted to, I could store this into some kind of intermediate temporary table, and based on the temporary table, create a ggplot. But I can also just take the entire table and just pipe it directly into ggplot, okay? And remember, in ggplot, the first argument is a table of data. And so that gets piped in, and then we set up our AES, okay? So here, it doesn't fit, so I'll show you the plot on the next slide. But basically, it says, take the Gapminder data. We're going to filter to just continent Americas. I'm going to group by year. And then as far as summarize go, I'm just going to keep the mean life expectancy and the count. And then on the x-axis, I'm going to keep the year. On the y-axis, I'll plot the average life expectancy. We'll join it together with a line and a point. And this is the resulting plot. So we can see, here was the average life expectancy in 1952. It was down here, 50-something. And then as time goes on, we see pretty steady improvement, not 100% linear. It's like kind of curving, and so it looks like it'll level off eventually. But yeah, kind of, pretty consistent improvement. Looks like every 10 years it's going up about 8 years or so. Okay, maybe 7.5. Okay. So that was for the Americas, and we can say, hey, let's repeat this for the different continents. Let's look at Asia, let's look at Africa, let's look at Europe, okay? So now I'm going to group by continent and year. We'll do the same kind of thing, calculate the average life expectancy, and so we get the average life expectancy in Africa in 1952 up through Africa 2007. We'll do the same thing for the Americas. We do the same thing. So now we have a big table, 60 rows, okay? Because I think there's 5 continents: Africa, Americas, Asia, Europe, and Oceania, which in our data set is just 2 countries. But we've got 5 continents, and then each continent has 12 years, 1952 through 2007. Okay, at 5-year increments. And so this is kind of our data set, Africa 1952 through 2007, America's 1952 to 2007. We got average life expectancy and so on and so forth. So we have that, and we can plot that. And so now my plot, this is the operation to create the summary table going from Gapminder. We group by, and then we summarize, right? So start off with Gapminder, group by, then summarize, okay? Summarize to calculate average life expectancy. Then take that result and make ggplot. In ggplot, on the x-axis, we'll put the year. On the y-axis, we'll put life expectancy, the average expectancy. And then we will color by continent. Okay? And so now I've got 5 colors. 1, 2, 3, 4, 5. Yeah. Okay. And so this is, this is what we see. All right. So across the different continents, we see different kind of these different kind of trend lines of how life expectancy has changed over time. Okay, for different parts of the world. Yeah. It's not. So I don't use count at all as far as plotting or anything like that, and then I'm not using it in this. But whenever I do a summarize, I always like to include count. Okay, so I don't, even though I'm not using count here, to me, count is going to be one of the first indicators that your summary option either went correctly or it went wrong, okay? So here, I'm seeing 52 kind of for everything in Africa. I'm seeing 25 for everything in Americas. So to me, that's a positive indication because it's saying like in 1952, there were 25 countries in the Americas that got summarized, and there were 25 in 1957, and so on and so forth. And so this to me is just kind of a reassurance that my summary calculations are going correctly. If you do count and you see like wildly different numbers, okay, you have to ask yourself, does it make sense? Like, does it make sense that Africa has 52 and America has 25? Yes, because, when, colonial powers were carving up Africa into different, countries, they chopped it up into, a whole bunch of pieces. So, there's 52 nations represented in Africa, and Americas there's 25 and so forth. Yeah, question?
Yeah. What's the point of also grouping it by the year, not just the continent?
Here?
For the graph you showed.
Well, okay, so so by grouping it by continent and year, I'm getting one. So if I group by year only, I will have 1 year for 1952, 1 year for 1957, and that's going to be for the entire world. So it'll be the entire life expectancy average for the entire world in 1952. I think that's what, oh no, this is just the Americas. But it's basically, you're just going to get one graph, and it's going to be for the entire world.
Well, for the one with all the 5 continents, the graph you showed.
Yeah. Yes, this one.
Yeah.
So each dot here is one country, or not country, one continent in 1952. This is Africa in 1952. This is Asia in 1952. This is the Americas in 1952. This is Europe in 1952. This is Oceania in 1952. And this dot is Oceania in 1957, Oceania in 1962, okay? If I group only by continent, then I would just have, I would have 5 dots, and it's for like the average of Africa across all of our historic data and time. So 1950 through 2007, we're going to get one number. Okay? Or if and we'll get one number for all of Asia from 1952 to 2007. I'll get just one number if I only group by continent. If I group only by year, I would just get 1 dot per year. I'll get 1 dot for 1952 for the entire world. I'll get 1 dot for 1957 for the entire world. So if I want different dots, this dot for Africa in this year, this dot for Africa in a different year, then I have to group by continent and year. Does that make sense? Okay. So we're grouping by continent and year. I'm calculating the average for each continent and year, and then I'm coloring it by the continent, and I'm graphing it right here. Yeah, as far as the counts go, I'm not using that directly, but to me, it's an indicator. It's kind of like a diagnostic thing that tells you, like, this is how many values. It averaged 52 values to get this average, is what it's saying when you look at the count. It's saying I took 52 numbers, okay, and I averaged them together to get this number. I took 25 numbers and I averaged them together to get this number. Okay, and so, if I actually pull this up, so if I pull this up, you can actually see the table itself. Let me, okay. So here's the table, and we can see Africa, America, Asia, Europe, and if I go, we can see Oceania. There's actually only 2 here, okay? And that's because in our data set, there's only 2 countries. It's Australia and New Zealand that count in the Oceania kind of continent group. And I guess that's fine. I don't know. I don't know what happens to, there's a bunch of kind of Pacific islands, Fiji, Tonga, a lot of, Polynesian countries, but they're not included in our data set. So by seeing the count, it's useful as a diagnostic as far as, like, am I averaging the right number of things? So yeah, I'm not using it as far as plotting goes, but it's useful to me to see if, like, I did my math correctly. Okay, here I just said, hey, let's filter down to the Americas and let's color by country, okay? And so this, here we're just looking at, I think there's 25 countries represented in the Americas. And so we have 25 things going on here. And I would say this plot's a mess, okay? This is not useful. And so I think probably, in your first homework, it's like, try to fit as many aesthetics for this MLB data. And maybe you did, like, let's do the teams associated with colors or something. It might have looked something like this, where you just have all of these colors all over the place. And, it's kind of useless, because if I say, all right, tell me about Trinidad and Tobago. Which line is Trinidad and Tobago? I don't know. I can't. These colors look exactly the same to me, right? Like Puerto Rico. I don't know, why is that? It should be, well, I don't know, it should be, but okay. Yeah. Puerto Rico is sometimes represented as part of the US and sometimes it's separated. I don't know. Okay, anyway. Anyway, we have these things, and it's really hard to tell, like, the difference between some of these colors, right? And you look at this, and it's really hard, and what is what? Okay, so not really great. So how would you want to do something like this, right? You have a few options. One is you can try to use a labeler, where you would actually plot a text label at the end of these things, but they're all going to kind of run into each other. Another is you can try to sort them, right? So right now the colors are sorted based on alphabetical order of the names of these countries, okay? And you have to kind of using your outside knowledge, you'd say, okay, well, what's this top line? Probably Canada, okay? But that's kind of based on, like, Canada being known as a generally wealthy nation with good access to healthcare. So probably going to be top as far as life expectancy goes. But yeah, hard to, without that kind of knowledge, it would be hard to kind of understand, right? So 25 colors, it's difficult to distinguish one. My rule of thumb, no more than 6 colors, okay? So think of like your, maybe 7, but you really want to start, how many are in the rainbow? Red, orange, yellow, green, blue, indigo, violet. Okay, we got 7 colors in the rainbow and that are named. I don't know. There's more than that, but we got 7 named colors in the rainbow, and that's probably the limit as far as colors go. Once you have to start using names like blue and blue-green and aquamarine, it's hard to tell. So anyway, we can filter the data further, and we can say, hey, you know what? Let's just look at 6 countries. All right, the 6 most populous countries in the Americas today are the U.S., Brazil, Mexico, Colombia, Argentina, and Canada. And so now we have 6 countries, and that's easier to distinguish. Like each color here is distinct enough for our eyes to kind of tell apart. And so here I said, these are my selected countries. We're going to filter just to country in the selected countries, and I've plotted it, and it looks like this. And this is okay, and we can see, all right, Brazil. So this does reveal something interesting. So Brazil and Colombia and Mexico all kind of started right around here at the same, and but their life expectancy has increased at different rates. Okay, Argentina started up pretty high, but was overtaken by Mexico somewhere in the late 90s. Okay, and then Canada and U.S. started similar, but Canada has kind of veered up higher, and U.S. hasn't made as much gains in life expectancy. Yeah, I don't know what's the cause behind all of this. Who knows? Okay, it's just revealing some interesting trends. Right, that's what we have. And with 6 colors, 7 colors, we can kind of distinguish these things. Okay. Another thing you can do, all right, is again, this is just in order by alphabetical order. Okay. Argentina, Brazil, Canada, Colombia, Mexico, and the United States. But you might want to reorder them by life expectancy. Okay, so we can say, hey, let's look at 2007 and arrange it there. You can't just say all of them together because the ordering has changed at different points in time, right? So you just have to kind of pick one year where there's like a clear ordering. So we're just going to go with the last one, 2007, and we'll put them in this order. And we'll put Canada at the top, then U.S., then Mexico, Argentina, Colombia, Brazil, and we'll have that. I am forgetting to do my job. Let me give you I'll go ahead and give you your first 2 answers today. First one is C as in cat, and second one is D as in dog. C and D. C as in cat, D as in dog. Okay. Oh, is there a question or something? Oh. There's a spider somewhere? I know. Okay. All right. Are we okay? Okay. So here I'm reordering by I'm like nervous. Okay. Countries by life expectancy. So we put them, so all I did was I put in a range, right? So hopefully we're starting to be able to read tidyverse commands. So start with Gapminder, filter it to this year. Actually, because I'm saying only use these selected countries, the filtering it to continent Americas is actually unnecessary, but I got filter to this year, filter to just these countries, select country and life expectancy, and then arrange in descending order by life expectancy, okay? And so this is going to be the order that we're going to color our lines, okay? And so here, I'm going to say, all right, all I did was I've just taken this column, okay, of country, now that it's been arranged, and I'm going to pull it, okay? And I'm going to assign this to country order, okay? So pull just takes the column and extracts it as a vector, right? And you guys have learned about vectors in data camp, and it just extracts that column as a vector here, okay? We have this weird thing that says levels 142, okay, and it like lists off all of the countries. And that's just because the country column contains information about kind of all of the countries. So even though only 6 countries are represented here, it contains kind of this internal ordering here, okay? But using that, okay, now I'm going to color based on those, I'm going to put the levels in that order of country order, all right? So I'm putting the levels of our country as far as the coloring goes into this order. Canada first, then United States, then Mexico, okay? So now I'm taking the Gapminder data, and then we're kind of filtering it to this, and then we're going to plot this. We've got the year, the life expectancy, and then the color. We're going to say color based on the country, but I want to specify a certain order, so I'm going to say levels is equal to the country order, okay? The factor thing allows me to kind of put it in this order. Factor is used for making a categorical variable out of something here. Okay, so the resulting plot looks like this. And I don't know if that makes it any easier to read, but maybe. And so now, you look at these lines and they're also in this order here. So you can say, okay, Canada up there, US, Mexico, Argentina, Colombia, Brazil, and we have it like that. We can also put labels on there if we want. We have the labeler. Right now, the label on this key is this, but it can, we can set it to be something different here. Yeah, question.
So it only changes the order of the key?
Yeah, so this is what we had earlier, okay? The order of the key is in alphabetical order, okay? And over here, the order of the key is now in descending order of life expectancy in 2007.
So if you're, not that it would make sense for this particular data, but if you wanted your color to be in a gradient, like a different, let's say it's slightly different shade representing each country.
Yeah.
Could you use the same line of code to specify like levels of country order and assign it to like a continuous gradient?
Yeah, so, right, as far as the color goes, okay, you can specify a manual color, okay? In this case, because the color is associated with a categorical variable, we wouldn't use a gradient. Gradients are used when you have a numeric variable for the color. So when you have like the color represents, I don't know, temperature, and you go from cold to hot or something like that. Now, you can specify a manual color scale where you're going to say this country gets, like, I want Canada to be red, and I want US to be blue, and I want Mexico to be green, or whatever. You can specify that, and you can choose your own colors, and that's certainly possible. But yeah, as far as the gradient goes, gradients can only apply to things that have a natural order. So the ordering for numbers makes sense. If you're going from like low to high, that could also work. As far as ordering these countries, there's not like, put these countries in order. That's like a weird question, right? What kind of order? Alphabetical order? Yeah, that works over here, okay? Order by life expectancy. Okay. What year? Life expectancy 2007. That's what we've done. And that's basically what we've done here, except because it's still kind of just this categorical thing, we would have to specify the colors ourselves. Okay. Okay. Sometimes you want to plot not just, so here each dot and line represents like individual countries, okay? But maybe you want to combine the individual countries and also like information about the average, okay? So like here we're on slide 34, but if I go way back to one of our earlier plots, this one was like the average of Americas, all 25 countries, right? And so we can kind of try to add that line. So this is kind of what I want to do is I want to take the average of Americas and plot this in here. Now, how do I add something like that to my plot? Okay. What I have to do is I have to consider, what am I plotting? The dots and the lines here come from the table where each row represents basically each dot represents a different country at a different moment in time. Okay, this dot is Canada in 1952. This dot is Canada in 1957. This dot is Canada in 1962. Each row represents a different country, different point in time, and each of those rows get plotted as dots here. Okay, when we have this line here, okay, I don't have dots here, but I've connected them with a line. This is the entire continent of North and South America in 1952, the entire continents, North and South America in 1957, North and South America in 1962. So that actually is a different table, okay? So this table is basically I filtered to get this table of like what's the continental average in 1952 and the continental average in 1957. What I had to do is I said filter to just the Americas continent, group by the year, and then calculate the average, okay? And so now I only have 12 rows, one for 1952, 1957, 1962, and so on and so forth, okay? And so I have two different tables, one for where each row represents a country at a certain moment in time, and then I have a different table where each row represents the entire continent at a different moment in time, okay? And so that is going to get combined right here when we are doing our thing, okay? So this part up here, this is our data that goes into our first ggplot layer, which is going to be each country in a different moment in time, okay? So we have Gapminder, and I've basically filtered to our selected countries, and I'm going to create a plot here where I've got the year and the life expectancy, and I'm coloring it by the country there, okay? But now I want to add a second line here, but remember the data for this second line comes from the other table where each row is the entire continent for the Americas, okay? And so here I have to specify, I've got a new datas table, okay? Here, I am not inheriting the data from Gapminder up here, okay? I'm using a new table, right? And so this new data table is this one that I've created over here, where each row represents the entire continent. So I've got data is equal to America's summary, and then I'm mapping year and average expectancy, and then I'm plotting it over here in black with a line thickness of 2. Yeah, question?
If the x and y axes are the same, why do you have to define the mapping again in the new geoline, even though it's already
I think because I'm specifying a new data source, I think the x and the y, I don't think it's going to inherit. Let me try it out. I think I would run into an error, but I will try this. Okay, where did it go? All right, so this is what we have. So if I get rid of this mapping here, I think I'm gonna error. Yeah, it says. Oh, okay. So one is if we look at this data table, this data table that gets piped into into ggplot. The columns are year and life expectancy. And then over here, my America's summary table, the columns are year and average expectancy. Now, if I rename this, I'm just trying this out here. Maybe if I call this life expectancy and I spell it exactly the same, maybe it'll be okay. I don't know. Let's see. So here, this has the exact same, the column name is exactly the same. So maybe it'll be okay without the mapping. Okay, yeah, it is able to do it if you use the exact same thing. But over here, I had named this average expectancy, which I think makes sense because we're doing it for the entire table. And so now it needs to recognize that this is going to show up differently here. Okay. Let me see. If I just mess something up here. I put X as average expectancy. Okay. Yeah. So now it's trying to fit on the x-axis. Okay, average expectancy in year, and average expectancy goes from, around the 50s to the 80s. And then years now, it's treating this as like year 50, during the height of the Roman Empire and stuff, right? So this is not going to work. Yeah. Okay, another question back there.
So instead of like adding a line with a different data set, couldn't you add a bunch of rows where the country value is equal to all countries, and then you just ggplot that like combined data frame?
Yes, that is also possible. Okay, and then you as far as this goes, it would be like Canada, U.S., Mexico, Argentina, Colombia, Brazil, and then you would have one more line that says like average of countries or something, right? The continental average, and that's fine. But that would require you to tack that data on, which is possible. Which here, let me see if I can do this. So I would have this. I have all right. Okay, so I have how would I do this? All right, so I have this is what we have here, and I want to call this life expectancy, and then I want to, so I would get rid of the count, summarize, and then I'd have to bind a new column of country equals, I don't know, continental average. And then, so we're going to get that. And then over here, I have, why isn't this working? Okay, so I have this country, continent, year, life expectancy. Okay, so I'd have to select just country, year, and life expectancy. Okay, and then we can try to join this together. And so how would I do this? I would all right, so I'll call this temp. you know, bind the rows. Bind rows with the temp. Okay, and so now, like, let me just view this. Okay, so here I've got Argentina, Brazil, Canada, Colombia, and then we've got the continental average. So far it looks good. And then we're going to punch that into ggplot. And, okay, well, I don't have my, let me just get rid of factor country, where I put in this custom order here. And so it would look like this, okay? Where now I have Argentina, and then I have the continental average, okay? But this, you know, the unfortunate thing is like the continental average looks exactly the same. It doesn't kind of get any special distinction because it's treated as like any other country here, okay? So if you do want to kind of treat it special, like you have to take something, you know, maybe create a new column or something. And so I don't know, to kind of say like these rows get special treatment. And I would say it kind of, you know, is less preferable to, I know it feels like maybe cumbersome to have to create a new data table and then use that as a different data source. But generally speaking, you want all of the rows in a table to kind of be the same unit. And you don't really want to be mixing countries along with continents at the same time. So it is, you know, what you're asking is possible. I would say less preferred. Okay, and I don't know, did I do anything else over here? Summarize total pop. Okay, this is just for the entire, okay, I think all I did here was I just said, let's look at the total population and just see how the populations of these things have grown. And so, you know, population of Asia grew over time. But anyway, okay, that's that. We'll wrap things up here. Last view quiz answer is A as in apple. A as in apple, and we'll wrap up there. Have a great rest of your day. I've got office hours, and we'll see you Friday.
Thank you.